So good evening, everyone. This is a short lecture in which we should be able to complete, as far as my calculation goes, the two optical instruments which are known as microscope and telescope. Now remember, this entire topic is about you remembering simple things. There is no explanation whatsoever for those things because those are the definitions of things, and that is how those things are defined. So there is nothing that could be explained over there. The only thing that you can understand is how you can remember those shortcuts, and there are different ways of remembering those shortcuts. So that is the only thing that we can do in this particular thing. We don't normally expect a question from this in JEE Advanced. Definitely, I've hardly seen any question from JEE Advanced. Yeah, but in JEE Mains, there is a slight probability that you might find a question from here. So we'll quickly go through this, and we will quickly go through. We have got to discuss two things: microscope and telescope. And you know what microscope is used for? Microscope is used for seeing smaller things and seeing them bigger. Yes or no? First thing in this thing is known as simple microscope. What is a simple microscope? We all know what a simple microscope is. A simple microscope is nothing but a simple convex lens. Do we understand? A simple microscope is a simple convex lens, and when you have an object placed between focus and the pole or the optical center, we will have a enlarged and virtual image of the object. So basically, a simple convex lens a simple convex lens can act as a microscope. It can help us see smaller things bigger if that smaller thing is placed between what? Placed between what? Huh? Placed between what? Placed between optical center and the focus. And this is a simple diagram of a microscope. I hope you can see this. Here, what has happened? We have a lens which is known as eyepiece. Here there is only one lens, so there is no eyepiece and objective. This is a simple convex lens, and this is the focus of this convex lens. This is the optical center. When the object is placed, and this is the object, when the object is placed between the optical center and the focus, the image that is formed is virtual, erect, and magnified. Do we remember this? Yes or no? This is the image that is formed, and as you can see, with respect to the object, that image is highly magnified, and this principle can be used to make a simple microscope. Now, what is there that you should see is this angle beta, that this eye or this mic or this lens substance at the object. If I and since we are talking about small angles, if I find the angle of this tan beta, this tan beta is literally equal to beta if the angle is very small. I hope you remember this. Yes or no? You remember this?
Yes,
Yes or
sir.
no? Yes, and you can see this beta or tan beta can be written as h by minus mu. Why I'm writing minus u? Because I'm taking sign convention into the consideration. Do we understand this? So this is the angle beta which the object subtends at the instrument. So remember this angle beta. This angle beta is the angle subtended by object at the instrument. Do we see this? Now, whenever we talk about microscope, we talk about the magnifying power of a microscope. The most important concept, the only concept that we have to understand about a microscope or a telescope is the magnifying power. How much can it magnify things? And how do we understand the magnifying power of any optical instrument? Through this small diagram that is drawn here. We imagine that there is no instrument, and then we look at that body and object, and we find out this angle alpha. This angle alpha is the angle subtended by the object at the eye which is unaided. We are not using any instrument. We are just looking at that object and finding out what angle that object subtends at our eye. Remember, for anything that we have to see, there must be a least distance from where we can see it. That is known as capital D. Do we know this least distance of distinct vision? Yes or no? Least distance of distinct vision, sometimes it is known as the near point. Do we know this least distance of distinct vision? D. If you don't know, you can write this D is known as least distance of distinct vision. Least distance of distinct vision. Some people also call it near point. Some people also call it somewhere near point, and it is equal to approximately 25 centimeters for a normal human eye. So these are the two angles that you must understand. One angle is the angle subtended by the object at the instrument, which is beta or tan of beta, or tan of beta. The other angle is the angle subtended by the same body but without any instrument. We call it unaided eye. And here we find out the value of this tan of alpha. What is the value of this tan of alpha? Which can be approximately written equal to alpha, and that will be equal to h divided by minus d. Yes or no? Do you understand this?
Yes, sir.
I'll give you 2 minutes to note this down, because if you understand this, the first part of this class is over. We have found out the only thing that we need to find out about a microscope, which is known as its magnifying power. How much the object has been magnified. How much the object has been magnified. Have you written this, everyone? Shall I move ahead? Okay. Now, the magnifying power, and try to understand, for different instruments we might have magnifying power defined in a different way. For this simple microscope, the magnifying power, MP, or magnification, is defined by this. It is defined by beta by alpha, simply equal to beta by alpha. Beta is the angle, visual angle, with the help of the instrument. Alpha is the angle without the help of the instrument. Beta by alpha. Now, if I just put the value of beta by alpha, which I would like you to do, what would I get? I've already given you the value of beta or tan of beta, and I've already given you the value of tan of alpha. Both are on the screens now. Can you tell me what will be the magnifying power of this simple microscope that we have made? Beta divided by alpha, how much will it come? How much does it come?
D by U, sir.
D by U, sir. That is the correct answer, sir. D by U. That is the answer that we are looking at. This is the magnifying power of a simple microscope. D by U is the magnifying power of a simple microscope. Now, whenever we talk about the magnifying power of any optical instrument, microscope or telescope, we will find it out in two different cases. What are the two different cases? The first case is when the image is formed, when the image is formed at infinity. Instead of infinity, you can also call it at far point. So there are two types of point. Infinity, which is also known as far point, least distance of distinct vision, which is also known as capital D or near point, when the image is formed at the far point. Now, when will the image be formed at the far point? What it basically means is, see, we have to find out this value of D by U. We have to find out this value of D by U. In first case, what will we do? In the lens formula, we will put the value of this V. Since it has to be formed at infinity, I will put the value of this V as infinity, minus infinity to be very exact, because this is a virtual image. And then from there, I will find the value of D by U. I'll get the value of U. U will be equal to F from here, and I'll put that value of U in the original equation. From there, I will get the magnifying power in this case, which is always equal to D by U, but in this case, I can write it as D by F because the final image is formed at infinity. This is how we will have to derive relation for magnifying power in each of the two cases. Do we understand this? So there are two cases for all the instruments. One is when image is formed at infinity. The other one is when the image is formed at D. So in both the cases, what you got to do is to find the value of D by U. In first case, when the image is formed at infinity, U, the object, must be at the focus. Then only image will be formed at infinity. Therefore, D by U becomes equal to D by F, and that is the first thing that you must remember.
U is equals to minus F.
Yes, beta?
U is equals to minus F.
No, U will not be equal to minus F. How did you get U equal to minus F? U is negative. You did not put the sign convention, right? Whenever we use any formula, you will have to put the sign convention. Are you getting my point, beta?
Yes, sir.
Once you put the sign convention, you will get U as equal to F. Okay, got it? Now, similarly, what you got to do is we have to find out the answer in the second case. What is the second case? The second case would be when the image is formed at D. Instead of calling it as D, some people may also call it the near point. What will be the formula in that case? How will you find out the formula? 1 by V minus 1 by U. 1 by V minus 1 by U is equal to 1 by F. You have to put the values of U, V, and find out the value of D by U. The value of V here is how much? The value of V here is minus D, and the value of U here is, with sign convention, minus U. From here, you have to find out the value of D by U, and then you put that value of D by U in the original equation. From here, you can find out the value of D by U. Can anyone tell me what is the value of D by U coming as? Don't have to waste time. You can just remember it. It will come as 1 plus D by F, and D by U is the magnifying power. So in this case, the magnifying power becomes 1 plus D by F. Do we understand this? Yes or no? No or yes?
Yes, sir.
This is what you got to remember about a simple microscope. Nothing can be changed. Nothing can be questioned because this is how it is. Do we get this simple microscope?
Yes, sir.
So whenever a question of simple microscope comes, the question will be pretty simple. they will give you the value of the focal length of the lens. They will tell you the least distance of distinct vision is 25 centimeters or 26 or 27, whatever. And then they will ask you what will be the magnifying power of the microscope. The question would be pretty damn simple. Let us first do compound microscope as well, and then we can do one or two problems on this. So the next heading is compound microscope. Have you heard about compound microscope? Have you heard about compound microscope, anyone?
Yes, sir.
What do you mean by compound microscope, beta? How does a compound microscope look like? Now this compound microscope, the simple microscope only had one lens. What about the compound microscope? Does it only have one lens?
It has multiple lens.
Compound microscope, the sort of microscope that we are going to do, only consists of two lenses. What are those two lenses called? The first lens, which is facing the object, is known as the objective. Do we understand this? The first lens, which is a smaller one, which has got a smaller aperture, smaller focal length, is known as the objective, which is the lens which is facing the object. Then I have a bigger lens, bigger aperture, bigger focal length, which is known as the eyepiece or the eye lens. Now, the object is placed in front of the objective. UO is the distance of the object from the objective. This objective makes an image, which is VO, distance from the objective. Then this image acts as object for the second eye lens. The first lens creates a real image. Do we see this real image? Erect object, inverted image. Do we see this? So the first lens creates a real image. What about the second lens? Does it create a real image or does it create a virtual image? Does it create a real image or does it create a virtual image?
Virtual image.
It creates a virtual image. So the final image, remember, is virtual. It is inverted. And it is magnified. It is virtual. It is inverted. And it is magnified. Do we understand this? Okay. Now, this is the diagram. Don't have to see much about the diagram. The only thing that we must be concerned about is the magnifying power of this lens. Now, how do you find out the magnifying power of this lens? If you can find out the magnifying power of O, what do you mean by O? What do you mean by O?
Object.
Objective lens, yes. And you multiply it by the magnifying power of E. E standing for the eyepiece. Do we understand this? Multiply them together. There are two lenses. Multiply them together. You will get the magnifying power of this lens, of this instrument. Now, how do I get the magnifying power of this eyepiece? This magnifying power of the eyepiece is same as the simple microscope that we had done. So this magnifying power is same as D by U. Do we see this D by U, my dear friends? This eyepiece is the same eyepiece that is put here. So magnifying power of this eyepiece is the same as the magnifying power of the original one. Do we understand this? This is the way I remember it. And this is the way probably you can remember this. So, one thing is known. This ME can be written as D divided by UE. There it was D by U. Here it is D divided by UE because it is IPs. Do we understand this? Yes
Yes, sir.
or no? Now look at this objective. This objective is a simple lens. And what is the magnifying power of a simple lens? V divided by U. Yes or no, my dear friends? So this is how I remember it. VO divided by UO. VO divided by UO. That is how I remember it, and that is how I will ask you to remember it. So the formula for this instrument magnifying power becomes VO divided by UO multiplied by D divided by UE. That is how I remember it. VO divided by UO is the magnifying power of the objective. D divided by UE is the magnifying power of the eyepiece, which is same as the magnifying power of a simple microscope. I'll give you 2 minutes. The diagram is not that important. In the diagram, what you got to understand is there is an object. The lens creates an inverted real image. That inverted real image acts as object for the second lens, and that creates a virtual magnified image, which is also inverted. Do we understand this? Yes or no? No, yes. I'll give you 1 minute, 2 minutes to note down this formula, because again we have to do two cases. What are the two cases that we have to do? What will be the two cases that we have to do?
Far point and near point.
Far point and near point. So the first case is image is formed at
Infinity.
yes, infinity. Image is formed at infinity. Infinity. Now I'll give you a minute to think about it and tell me what will be the formula. You know the formula. That's why I'm asking you. What will be the formula of magnifying power in that case? And the answer is and the answer is V naught divided by U naught remains like that. And instead of D by UE, what will I write? D by FE. Do we understand this? How I got this? Yes or no?
Yes, sir.
Same na? Simple microscope, same na? Only V or V naught by U naught is multiplied, same na? Yes na? No na? Or what na? Do we understand this? Yes or no?
Yes, sir.
I can write this in a different way. V naught by U naught is the magnifying power of a simple lens. I can write it as FO divided by FO plus UO, magnifying power, simple lens, into D by FE. Or I can also write it as, the more the number of ways you remember, the better you are going to be. FO minus VO divided by FO. The more the number of ways we remember it, we will be doing better, into D by FE. You can also write it as H. This is H1 and this is HI and this is HO. Let us say this is HO, this is HI. So I can also write it as HI divided by HO into D by FE. Do we understand this, my friends? Please raise your hand so that I understand that. Yes, we are on the same planet, in the
Yes, sir.
in the same galaxy. Now, one more thing that is asked sometimes here is the length of this microscope tube. Now, if you have used this microscope, whenever you adjust the lens, the length of the microscope tube changes? Yes or no? The length of the microscope tube changes. Now look at the diagram. The diagram is right in front of your eyes, and I have also highlighted what is the length of the tube. In this case, can you tell me what will be the length of tube of this microscope? What will be the length of tube of this microscope? What will be the length of tube of this microscope? And the answer would be V naught plus Fe. Yes or no? Because UE is equal to Fe. The length of the tube is nothing but the addition of VO with UE without the sign convention. Do we understand this? This is the length of the tube. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yeah, this is the length of the tube. From UE to E. That is the length of the tube. This is the case when image is formed at infinity, my dear friends. Now quickly in 5 seconds we will write the formula for image formed at D. Fatafat write image at D, the formula for image at D, and I quickly write it. MP, magnifying power, will be V naught by U naught into what? Into what? Ah? 1 plus D by Fe. Do we understand this? Yes or no?
Yes, sir.
Can you write the other three formulae on similar lines?
Yes, sir.
Please write it fast. Can you also write the length of the tube? Length of the tube in this case will be V naught plus UE modulus. Why I'm writing UE modulus? Because by sign convention, UV will be negative. I don't want the negative value. I want the positive value. Do we understand this? Yes or no? No or yes?
Yes, sir.
Fatafat, sir, because I have two questions, sir, which you have to solve in 2 minutes. Then only we can cover the last thing, which is telescope. So 2 minutes you have to solve two simple problems. And I hope you have noted down this. Yes or no? No or yes?
Yes, sir.
Yes, sir.
No, sir. Don't take so much time, sir. Otherwise, this class will stretch into the next class, sir.
Completed, sir.
We are way behind the code, sir, and this is the problem, sir. And do it fast, sir, and give me the answer, sir. A thin convex lens of focal length 5 centimeters is used as a simple microscope by a person with a normal near point of 25 centimeters. What is the magnifying power of the microscope? It is not said where the final image is formed. Give me the answer in both the cases. I would be happy. Huh? Jaldi.
Sir, answer is 6.
For which part? Infinity or near point?
Near point, sir.
Yes. Near point is 6. Yes, I thought you had said ulta. So magnifying power in case of near point is 1 plus D by Fe. Yes or no? Just put the values, get the answer, and stay happy. 6.
Sir, for infinity, it is 5.
For infinity, it will be D by Fe, and the answer is 5. Yes or no? No, yes. Everyone got this?
Yes, sir.
Okay, sir. Everyone has noted this down? Okay. Can I give you
Sir,
the
1
next?
minute.
Okay, I'll wait.
Done, sir.
Done, sir. Then I can give you the next question, sir.
Yes, sir.
Sir.
Then that is the next question, sir. And all the best, sir. A compound microscope consists of an objective of focal length 2 and an eyepiece of focal length 6.25. So the focal length of the objective is smaller compared to the focal length of the eyepiece. Separated by a distance of 15 centimeters, so that's 15 centimeters, my dear friend, is the length of the tube. How far from the objective should an object be placed in order to obtain the final image at A, near point, B, infinity. Also find the power in both cases. Also find the power, magnifying power in both cases. Shall I do it for you? So, how far from the objective should the object be placed? So, what they are asking for us to find out? They're asking us to find out the value of UO. Yes or no?
Yes, sir.
They're asking us to find out the value of UO. What is given? Final image is formed at D, 25 centimeters. So basically, they have given us the value of VE. Yes or no? And that is minus 25. We know this. Yes or no? It's a virtual image. Yes or no?
Yes, sir.
So I apply the formula 1 by V minus 1 by U is equal to 1 by F. I apply this formula for which lens, my dear friends? I apply this formula for the eyepiece. Do we understand this? I apply this formula for the eyepiece. What all things I know here? I know the value of V as minus 25. I can write it as E. I know the value of this focal length of this lens. Eyepiece is 6.25. Yes or no? From here, I can find out the value of UE, which is the distance of the first image from the eyepiece. Can you get me the value of UE from here? VE is given as minus 25. FE is given as 6.25. If I get the value of UE, what will be the value of UE?
S- 5, sir.
Plus or minus? Minus 5, no?
Minus 5, sir.
Okay, then I know that the length of the tube is 15 centimeters. Yes or no? No or yes? This is the length of the tube given as 15 centimeters. I know the value of UE. I can find out the value of VO. VO will be equal to 15, which is the total length minus UE. Do we remember that diagram? Yes or no?
Yes, sir.
So my objective VO will be 10 centimeter on this side. Now, bacha, I know the value of VO. I know the value of FO. I have to calculate the value of UO. So I will again apply the formula, my dear friends. Which formula? 1 by VO minus 1 by UO is equal to 1 by FO. What is the value of VO, my dear friends? For the objective. What is the value of VO? Tell me, tell me, tell me. It is plus 10. Yes or no? It's on the other side. Yes or no?
Plus 10, sir.
Well done, sir. UO, I don't know. But FO, I know. How much the value of FO? 2 centimeters plus 2. Yes or no?
Yes, sir.
Yes, sir.
From there, you can get the value of UO. Once you get the value of UO, you can calculate the rest of the things. Yes or no? No or yes?
Yes, sir.
Yes, sir.
Can you tell me the value of UO from here?
Minus 2.5, sir.
Minus 2.5 centimeters to get the value of UO. Now you know everything. You can calculate the magnifying power. Yes or no?
Yes, sir.
Can you do part B as homework? So that I can complete this telescope wala part. Can you do this part B as homework? What you have to do?
Sir.
Yes? Any problem, beta?
Yes, sir.
Yes, beta, what?
Problem, sir.
What problem?
No problem, sir.
Okay, so you can do this as homework so that I can finish that telescope wala part also. Okay, shall we go ahead?
Yes, sir.
Because again, it is all about just looking at the diagram and looking at a question, and we are done. I don't want to extend it into the next class. Shall we move on to the telescope part? Yes or no?
Sir, for
Yes.
infinity, answer is minus 6.
For infinity, the value of the value of UE will come as 6.25 because it will be placed on the focus. Yes or no? So the value of VO will be 15 minus 6.25, 8.75. From there, because it is coming in decimals, the final answer will come in decimals. So it will be a lot of calculations, and you will take 3 or 4 minutes to calculate it. In that 3 or 4 minutes, I can probably finish the astronomical part. Yes or no? That is why I'm not doing it. I hope you can. Manage it. Yes or no?
Yes, sir.
Okay, so
Sir.
let's not waste any time and let's move straight away into telescope. And this is telescope. The good thing about telescope is these rays are coming from infinity. Do we understand this? These rays are coming from infinity. Do we understand this? Yes or no?
Yes, yes, sir.
So the first image will be formed at the focus of the objective. Yes or no? First image
Yes,
is formed at the focus of the objective. Then this image will act as an object for the second lens. Yes or no?
Yes, sir.
And you will have a final inverted image, which will be virtual image. Again, you see an alpha here. Yes or no?
Yes, sir.
And a beta here. The magnifying power of this instrument is this beta, which is the angle subtended by the final image divided by alpha, which is actually angle subtended by the initial image. Do we understand this? Yes or no? Beta
Sir.
by alpha. Yes, beta. You don't have to draw that diagram. It's just to show it to you. Just have to remember these values. Yes. Do you have anything else to say?
Sir, zoom the diagram, sir.
You don't have to draw the diagram. The diagram does not concern. You just have to remember the formula. The diagram does not concern us. I don't want you to spend too much time in the diagram. Okay, you just have to remember the formula that is coming. And the formula that is coming is beta by alpha, which will be equal to FO divided by UE. That is the formula that we are concerned about. If you want to see the diagram, I can show you the enlarged view of that diagram, but that will not serve much of a purpose. Since it does not serve any purpose, that is why I have not shown you, because this thing should be done in your board wala tayari. This is not a part of actually JEE. That is why I have not shown you the diagram, but still, if you are interested, I can make it as big as possible. This is the biggest I can make it. And if it serves any useful purpose, well, have a look at it. This is how the point that I had to tell you was the first image is formed at the focus of the objective, and the focus of the IP is behind it. That means the object is now between the focus and the center of the lens. So you will have a enlarged virtual image backwards. This is VE, this is UE, and UE plus F naught becomes your length of the telescope. And this alpha and this beta by alpha, this beta by alpha is your magnifying power, which will come as F naught by UE. So magnifying power will be equal to beta by alpha, that will come as F naught by UE. That is what you should remember. With a negative sign. I forgot the negative sign. Minus F naught by UE. That is the formula you should remember. This diagram will only come in your board exam. You have time to remember this diagram. Here only you have to remember minus F naught by UE. That is all that we need. Okay. Minus F naught by UE. Again, we will have two cases here. You don't have to draw a very illustrative diagram. Just draw one image and then draw the other image. That's it. Don't spend your time in making a very accurate diagram. It's not required for JEE Main. Shall we move ahead?
Done, sir.
Shall we move ahead, beta?
Sir, 1 minute.
Okay. Everyone seems to be enjoying the diagram. Okay.
Done, sir.
Okay, sir. Shall we move ahead, sir, or you're still okay? Then draw the diagram. I'll complete this in the next class.
Sir, 1 minute.
Okay, do it. Do it. Not a problem. If you have to draw it, you have to draw it. Draw it. Not a problem. Whenever you are doing something nicely, do it nicely. Don't worry. Do it nicely. Two angles are here, alpha and beta. And we have to find out the ratio of beta by alpha, nothing else. And this ratio of beta by alpha will come out to be as F naught by UE with a negative sign. Shall I move ahead?
Sir, please scroll the slide little bit up.
What's wrong with the slide? You can't see the slide? Okay. Better now?
Done, sir.
Done, sir.
Everyone? Okay. Then we have got to see that the magnifying power is minus f naught by UE. First case will be image formed at infinity. Again, you have to find out the value of UE. UE will be equal to FE. So in that case, the magnifying power will become minus f naught by FE. Yes or no? We agree on this? And length of the tube. Length of the tube, let us finish the formulas here. Length of the tube will become f naught plus fe. We all understand this?
Yes, sir.
The second case will occur, bacha, when the image is formed at D, which is the least distance of distinct vision. Again, we have to do the same thing. I will write the formula. I will just show it to you. 1 by VE minus 1 by UE is equal to 1 by FE. I will put in place of VE, I will put minus D. In place of UE, I will put minus UE. Then calculate the value of D by UE, 1 by UE. I will end up with this formula for magnifying power. I don't have to do all of this. I will end up with this formula, and this formula looks something like the previous formula, but the thing is, the terms have been reversed a bit. So remember, the terms have been reversed a bit. So be careful about the two formulae. You will have to remember them, because a question, if it comes, it would be a direct question based on this. This is the magnifying power, and the length of the tube in this case, as always, it is always equal to f naught. F naught is fixed because the first image is coming at f naught plus the magnitude of UE. Why I'm writing it the magnitude? Because UE is negative, that's why. So these are the concepts of microscope and telescope. The questions that are on these things are very simple. They will give you the values and they will ask you the answer to this. If possible, I will give you one or two questions on telescope and microscope in the next class, and we can wind it off then, okay, if you want. Otherwise, we can move ahead and move into the next territory, because there is nothing that we have to do. Just have to put the formulas here and get the answer. And again, the probability of this coming, what I feel, may be very less, right? Because you have an entire chapter based on optics. This is a very small part of that chapter, and I don't think question will come from here. Okay? Do we understand this in any case?
Yes, sir.
There are three formulae or two formulae from whatever angle you see. That is what you have to see. The first formula is for the compound microscope. The magnifying power of the compound microscope, in two cases, you have to remember it. The magnifying power of an astronomical telescope, in two cases, you have to remember it. In both cases, the first formula is D by UE. In second case, the formula is minus F naught by UE. D has been replaced by F naught. UE still remains UE. So that is the way I remember it. I hope you can remember these two formulae, and in the next class, we can move on with the next chapter, probably. Can you do questions on this on your own?
Yes, sir.
Yes, sir.
Okay. Then we will begin with the more important chapter, because wave optics is more likely to come rather than this. So we will try to wind up wave optics in two classes. That's what I am hoping for. So let us see, and see you in the next class. Take care. Have a nice day, beta. Bye-bye.
Bye, sir.
Bye,
Bye,
sir.
Bye.